All right, as we talked about in our last video, IEEE 1149.1 is the specification that we're going to be talking about. Now let's get into some of the details of how the architecture works. First of all, you'll see there's two ICs here on the screen, and the way this will typically work is that we will bus through the device the information that we need by using a clock serial bus. So if you look here on the TDI pin, you can see that we have a serial channel and we can clock data to each of the pins down through the device and on to, in fact, the next device, out, continuing the chain and looping back to our connector. So that is the serial interface, and the way the testing will work is that silicon vendors, in order to support IEEE 1149.1, need to add cells in between the external pins, the outside world, and the core logic of the device, whatever it may be it a microprocessor, FPGA, or CPLD, or something like that. Most devices today, modern devices, have this extra silicon for JTAG boundary scan. So these extra cells can be either used to read values from the pins or write values to the pins, and those values are clocked in and out using this serial chain. Think of it as a big long register. To get access to this, we use something called the TAP, or Test Access Port, and that is comprised of 5 pins. The fifth is optional. The pins are TDI, TDO, TMS, TCK, and TRST, TRST being the optional pin that's often used on microprocessors. So using this tap, we can access a state machine and various registers. So for instance, this register is called the boundary scan register, and it gives us access to these pins around the device. So how can we use this mechanism to do testing? So the first kind of testing that we're going to be doing is just simply reading values. So we can read the pin, clock the data out, and see that this was plus value or a 1. Here we could read the value and see that it was a ground. Here we can test a pull up or pull down. So that is the initial methodology for testing. In addition, we can test for shorts and opens as well as bridging shorts. So using this technique, you can do quite a bit of testing without adding any additional test points. In our next video, we'll talk about how to use so-called non-JTAG or cluster devices and how we can test those using the same technique.